Our next definition is the S minus P time method. So S dash P is a math problem. It's S minus P. So we're going to see what that means. It's the most common method by which seismologists can find an earthquake's epicenter. We just learned what the epicenter was, and this is the method to figure out where it is. So the way we do that is this. Now this picture right here, this little piece of paper should look familiar. And if you know what it's called, feel free to shout it out at your screen. This is produced by a seismograph, but the piece of paper is called a seismogram. So this is what we're looking at. Right here, this first like little tiny line, there's basically no action, it all looks the same. This is just called background noise. So this is just random little fluctuations that happen all the time. Nothing important is happening there. Now right here, right, so the earthquake actually happens right here. But we don't know about it because it takes time for it to reach us. So it's not until right here, about 2 minutes in, because this is minutes on the x-axis right here, 2 minutes and 20 seconds, I believe, is when the first earthquake arrives, or at least the first P wave arrives. That's when we first notice it. So right here, this is where we mark P wave, right here. Now over here, this is when the S wave arrives. So right here, this is the second time that happens. Okay, we have our P wave, we have our S wave. Perfect. Last, we have the biggest waves, which are the surface waves, but they don't help us predict where the epicenter is, so we're going to ignore that. So we have our first P wave, which is a little over 2 minutes. So that's 2 minutes and 20 seconds, we'll call it. And then this one is at exactly 4 minutes is when that one arrives. So it says the S minus P interval is where we're going to take the S wave, and that time is 4 minutes. We're going to subtract the P wave time, which is 2 minutes and 20 seconds. And when you do that, you have about 1 minute and 40 seconds left over. And now we can use this to determine where the epicenter is. So this is essentially the idea behind the S minus P time method. So let's take a look at another way to do it. So right over here, now we have an x-axis. The x-axis is right now, it's the distance from the earthquake. So if the earthquake happens over here, this A1 right over here is 2,000 or a little bit less than 2,000 kilometers away. This one is almost 6,000 kilometers away, and so on. Okay. Over here, this is the time after the start of the earthquake. So 5 minutes after, 10 minutes after, 15 minutes after. And we have two different waves that are on here, two different lines. This measures all the P waves, this measures all the S waves. Notice that in time, this is shorter right here because P waves travel faster, S waves are slower, so they have a longer one. So let's take a look at it. In this first A wave right here, at the first seismograph station, because this is where the earthquake is, the seismograph station is not right next to it, it's some distance away. So right over here, the first wave comes in at, what are we going to estimate that as? 4 minutes later. Okay, so 4 minutes later, we'll round up, we'll say it's 4 minutes later. And then over here, this will be what, around 6 minutes later, something like that, 7. So let's say 7. 7 minus 4, right, the S wave minus the P wave is about 3 minutes. So that's our first unit of measurement, will be 3 minutes. Okay, now we go over here. For this one, we can look over here. We might say that that's 9. Yeah, let's call it 9. And then over here, this one will be, if we look to the left, halfway in between, we can call that 18 maybe. Sure. So now we have 18 minus 9. That would be 9. Okay. And does this look about 3 times bigger, that gap between this one? Yeah, I'd say roughly. Now on our final seismograph station, this one we'll say is about 12. And this one over here is about 23. So you take 23, you subtract 12, the S minus the P, and you have 11. Now that you take all these distances, if we take the first one over here, right, we can now, let's just say right over here that this is where our first station was. And we said that it was, let's say it was Boise, that we took it out of. Boise's roughly in the middle there. Okay, that was our seismograph station that detected it. And all that we know is we don't know what direction it came in. All that we know is the distance. So that means that it's somewhere on this line. We know that it is 3 minutes away, and that corresponds to a distance away. So if we translate that, let's say it's, I don't know, 100 kilometers or something like that. So it's 100 kilometers away. It's any direction it could be. It's just somewhere on that line. That's what we know for sure. So one seismograph station only tells us that it's somewhere on that line. Again, it tells you the distance, but not the direction. So somewhere on that line is where it falls. Now when we take the data from the second one right over here, well, let's see what that looks like. Over here, same information. I know it's not accurate to it, but just go with me on this. So we'll say that the seismograph station is in the middle here, Helena, and it's the same information as last time. We don't know what direction it's in, but we know that it's somewhere on this yellow line, right? But now that we have two seismograph stations, we know that it has to both be somewhere on this yellow line and somewhere on this green line. It has to satisfy both of those at the same time. So it obviously can't be at that point right there because it's not on the green line. So what we know is that it could either be at this location right here because this is an intersecting point between them, or that one right over there because it intersects there as well. Those are the only two locations. Two seismograph stations narrows it down to two possible locations. Finally, we get our third piece of data, and you need a minimum of 3 seismograph stations to pinpoint what it is. So when we look at our third one, oh, and this one's big. We'll say that this one started at Jefferson City. Why not? Okay. It's somewhere on this red line, but also somewhere on the yellow line and somewhere on the green line. So this satisfies 2 out of the 3. This satisfies 2 out of 3. A lot of them do that. The only one where they all intersect is right here. So that means that the location of the epicenter is slightly to the east of Salt Lake City, and it'll be right there. And that's how you figure it out. There's our point for the epicenter of the earthquake. And this is how seismologists pinpoint the epicenter.